Hey there, Doc Bateman here. This is part 2 of my Physics Done Right lesson about units. If you haven't seen part 1, please go watch it first. In this video, I'll do some more examples and then talk about scientific notation, the proper way to write units, and how prefixes work and how to write them. Please click like and subscribe below, and also leave me a comment. If you think these videos are helpful, please share them with a friend. Let's get started. Next, let's do a time conversion. How many seconds are in January? So I write down January. I need that to cancel, so I put January in the denominator, and I know that January equals 31 days. Now let's work our way down to seconds. Need a day in the bottom to cancel. 1 day is 24 hours. 1 hour is 60 minutes. And 1 minute is 60 seconds. Let's check the cancels. January, January, day, day, hour, hour, minute, minute, and what I have left is this single unit of seconds, which is good because that's what I want. Now collect numbers. 31 times 24 times 60 times 60, and the unit I had left was seconds. This equals a very large number, 2,678,400 seconds. Done. For our final conversion example, I wanted to show you how to do a volume conversion. In this question, a concrete truck holds 10 yards. Yards is a jargon term that means cubic yards. So I have 10 cubic yards of concrete. How much is that in cubic meters? I need one conversion factor, and that is 1 meter equals 1.094 yards. Draw a bracket. 10 yards cubed. So I need yards in the denominator. I use my conversion factor. But I'm not done. I have 1 yard here. I've got 3 yards up there. So I have to do the same conversion 3 times to cancel all 3 of those yards. So let's do it again. And a third time. Now let's check the cancels. 3 yards cancels 3 yards. So I have left a meter and another meter and another meter. So that's meter cubed, which is good because that's what I want. Now gather the numbers. 10 over, I'm going to shorthand this, 1.094 cubed, and the units I have left are meters cubed. And a calculator tells me that this equals 7.64 cubic meters. Done. Let's talk about notation. When you write quantities with units, there's a convention. Convention means a standard practice. And this convention says if the unit is based on a person's name, then you capitalize the abbreviation, but if you need to write out the full word for the unit, don't capitalize it, because that would confuse people whether you're talking about the unit or the person. Let's give some examples. The unit of force is called the Newton, after Sir Isaac Newton. So if you write the full name, you don't capitalize it, but if you abbreviate it, like here, the abbreviation is a capital N. The same for the joule, the watt, the amp, the volt. There are many units that are named after physicists and other scientists and engineers. So that's the convention. Capitalize the abbreviation but not the complete word. Next, let's talk about scientific notation. Scientific notation is a way to write very large or very small numbers in a compact way and to keep track of where the decimal point is. So here's the recipe. If you move the decimal point left, then you multiply by 10 to the positive whatever that number is. If you move the decimal point right, then you multiply by 10 to the minus whatever that number was. For example, here I have 10 million written out. I want to move the decimal point here right after the 1. So if I move it, I have to move it 1, 2, 3, 4, 5, 6, 7 places left. Since I move left, that means I have 10 to the 7, 1.0 times 10 to the 7. Then I have this very small number. I want the decimal point to be right here after the 1. That means I have to move this decimal point 1, 2, 3, 4, 5 places to the right, which means I have 1.0 times 10 to the minus 5. And just for fun and a really good illustration, there's a nice video that was made in the late 70s called Powers of 10, and it nicely illustrates the very large and the very small. It's on YouTube, and I'll put a link below so you can go watch it. It's not very long, and it's very illustrative of powers of 10. Next, we talk about prefixes. Units can be scaled up or down with prefixes. Prefixes that multiply or scale up are written with capital letters, and prefixes that divide or scale down are written with lowercase letters. But there are exceptions to this rule. The first 3 multiply or scale up prefixes, deca, hecto, and kilo, are written with lowercase letters. Really, the only one you need to remember is kilo, lowercase k, because deca and hecto are not widely used. The table next lists the standard prefixes. Notice that they mostly step up or down by a factor of 1,000, which is 10 to the 3rd. And here's the table of prefixes. Notice that right here in the middle is 10 to the 0 or 1. The prefixes that make units bigger go up from there. Deca, hecto, and kilo, notice that they are lowercase like I mentioned. Kilo is 1,000, mega is 1,000,000, giga is 1,000,000,000, tera is 1,000,000,000,000, and so on. Then the prefixes that make units smaller go down from there. Deci, centi, milli, like you've heard of centimeter, that's 1/100th. Milli, that's 1/1000th. Here's a strange one. This is micro, and it's represented by a lowercase Greek letter mu, and it means 1/1,000,000th. Nano, 1/1,000,000,000th, etc. on down. So there you have it. I hope you know a little more about units now, how to do conversions, and what prefixes are. Please click like and subscribe below, and leave me a comment. If you think these videos are helpful, please share them with a friend. Thanks for watching.